Oil treaters. In this video, we will talk about what treaters are and how do they work. What is an oil treater? First thing we need to understand is that oil comes out of the ground as an emulsion. An emulsion is a mixture of oil and water. Treaters are typically used in the final stage of processing this emulsion in order to remove the remaining parts of water from the oil. The main purpose of the treater is to produce high-quality pipeline spec oil. Here, we see the internals, which come in different variations, but are vital to any treater. In the bottom left, you'll see the fire tube, burner, and the exhaust stack. Collectively, this system provides the heat duty to the process. It is important to heat the oil to an appropriate temperature as it will improve separating conditions. As oil is heated, viscosity is lowered, which provides favorable coalescing conditions. The inlet device is a standardized feature which is used to control inlet momentum and can come in many variations. The flow controlling plate gives the designer the ability to introduce more favorable flow profile. The coalescer is used to assist in water droplet formation and strip any mist from the gas. The oil collector box is where the final pipeline spec oil is removed via the oil outlet. The vortex breaker prevents vortex creation during the water phase removal. In this video, we will be talking about the 5 main different types of treaters available and what their strengths are. Vertical treaters, free water knockouts, bucket treaters, pack treaters, and electrostatic treaters. Vertical treaters are primarily used for low volume and high water content applications. They are a traditional design and were one of the first types of treater commonly used in the industry. They work well for easy-to-treat oil in situations where there is low or no gas flow. Free water knockouts. You can still think of these as a treater, but we call them a free water knockout, FWKO for short, because they are primarily used upstream of treaters to get rid of as much water as possible, aka knock out the free water. The main difference between the FWKO and the bucket treater, which we will discuss next, is the location of the fire tube. As you can see in the diagram, the fire tube is placed higher in the vessel, so there is more room for water. Bucket treaters. This is a very popular model of treater. This unit is a time-tested and industry-proven design. They are typically used downstream of free water knockouts to remove the remaining water entrained in the oil. They are best suited for medium to light oil and have an end controls design. End controls means that the majority of operator control happens in the end or head of the vessel. Packed treaters. These are named the packed treater as all the gas has been stripped off in the front section and the rear section is packed with oil. Some manufacturers call these treaters horizontal vertical flow, or HVF for short. These treaters are fit for use with most oils, but it shines in harder to treat applications. Due to the way the internals are positioned, these treaters are side controlled. Side controls means that the majority of operator control happens along the length or side of the treater. The electrostatic treater is very similar to the previously discussed pack treater, except it adds an electrostatic field that encourages water droplet coalescing. While this is the most expensive treater, it can, on average, double treating capacity. Electricity is introduced into the vessel via a transformer. This transformer is connected to electrostatic grids in the packed section. A fire tube is what creates the heat inside the vessel in order to assist in emulsion separation. As you can see in the picture, a fire tube is in a U shape. The left side has a burner mounted to it, which can range in BTU value depending upon the unit. The heat travels the length of the tube, turns around, and exits out the other connection via the stack. There are many optional components which can be installed on an as-required basis. These are specialized vessel internals to help combat specific problems an operator may encounter with his treater. The inlet cyclonics is attached to the inlet inside the vessel. The emulsion comes in and travels down the vertical tubes, which creates a cyclonic motion. This can assist in degassing and defoaming. Coalescing sections are installed so that when the emulsion flows through it, It promotes water droplet formation and decreases the required retention time. Plug flow baffles are a type of weir plate installed in the vessel. Due to the way the emulsion interacts with it, it can promote a more linear flow path. It is primarily installed in bucket treaters. Desludge systems are used in some applications. A sludge or rag layer can form in between the oil and water interface. This can disrupt the operations of the treater. The desludge system, or sometimes called rag layer pull-off, can remove this from the treater. Desand systems are used in order to clean the sand out of the bottom of the vessel. This is done during regular operation, which reduces downtime. If a treater is installed in a sand-prone service without a desand system, the unit would regularly need to be drained and cleaned out. The CSA B149.3 relates to a new industry-wide standard in regards to how combustion systems are installed and approved. Our shops follow this code and get the burners field certification ready. Once the equipment is on site, a field certification is required by a certifying body. This is a new requirement as of January 2015. NRG can also help retrofit existing equipment to have them be 149.3 compliant. Questions about anything discussed in this video? Please let us know.